Emirates Driving Institute, commonly known as EDI, stands as the most established and largest driving school in Dubai, having served the community since its opening in 1991. With thousands of learners passing through its branches every month, EDI plays a major role in shaping safe and professional drivers across the UAE. The institute operates a large network of training centers, lecture halls, reception areas, administrative offices, and testing yards, supported by a fleet of blue and white training vehicles that have become iconic throughout Dubai. These include light cars, heavy trucks, buses, forklifts, and motorcycles. More than 1,000 instructors work across multiple EDI branches, creating a complex, high-volume environment where efficient operations are essential. The learner journey begins the moment they walk into the building, interact with the reception staff, and collect registration receipts or booking confirmations. These interactions highlight how closely the Institute's operations rely on both physical and digital systems. A critical part of the learner journey is the booking system, where students select lesson timings, branches, and instructors. The booking process is primarily conducted through the EDI mobile application or the official website. Ideally, the system should allow students to log in, review available time slots, and confirm their appointments with ease. However, many learners face recurring difficulties such as unavailable slots, slow loading pages, and repeated refreshing. These issues lead to delays in scheduling lessons and create frustration among learners. The inability to find open slots often causes students to check the system multiple times throughout the day. This experience not only disrupts the learner's progress, but reveals deeper operational inefficiencies within the booking mechanism itself. Because EDI operates at a massive scale, even small issues within the booking system affect thousands of learners simultaneously. For instance, when a slot appears unavailable despite an instructor being free, it creates a mismatch between actual and displayed capacity. In some cases, instructors have idle periods, even though many learners are actively searching for appointments. This shows that the system lacks real-time synchronization. As a result, resources that are physically available, such as instructors and cars, cannot be utilized because the digital system fails to communicate accurate information. This disconnect creates operational bottlenecks, reduces utilization rates, and slows down learner progress. To understand the complexity of this issue, operations management theories provide valuable insights. The 4Vs model, volume, variety, variation, and visibility, describes the nature of EDI's operations. Volume is extremely high because thousands of booking transactions, lesson attendances, and assessments occur daily. High volume means that any inefficiency multiplies rapidly. Variety in the service is relatively low because most training programs follow standardized formats. Whether a learner is preparing for a light vehicle or a heavy vehicle license, the structure of lessons and assessments remains consistent. Variation in demand is noticeable. Learners tend to book more during evenings, weekends, and holidays, while afternoons on weekdays show lower demand. This creates predictable peaks and troughs. Finally, visibility is very high. Learners directly experience each part of the service, from booking their lessons to interacting with instructors in EDI cars. Any issue, whether digital or physical, immediately affects the customer's perception of quality. High visibility means that operational weaknesses cannot remain hidden. They directly influence learner satisfaction. The challenges linked to the booking system also become clearer when viewed through lean management principles. The most obvious form is waiting. Learners wait for available slots, wait for the system to load, and wait for confirmations. Another form of waste is overprocessing, where students perform repeated actions such as refreshing the app or checking multiple branches just to find open slots. This not only wastes time, but adds unnecessary effort to a process that should be straightforward. Additionally, underutilization occurs when instructors are available but not matched with students due to system delays. This mismatch highlights a lack of workflow integration between the digital booking platform and real-world operations. ServeQRL, a widely used service quality framework, also offers insight into the underlying issues. The main gaps appear in reliability and responsiveness. Reliability refers to providing accurate and dependable service, but when slot availability is unclear or inconsistent, learners lose trust. Responsiveness refers to the speed and effectiveness of service, yet slow updates and delayed notifications reduce user satisfaction. Learners expect a dependable and transparent digital experience, especially because EDI deals with essential services that influence personal progress and licensing timelines. When reliability decreases, learners often resort to calling the reception desk, standing in queues, or visiting branches physically, adding further strain to the system. The theory of constraints identifies the weakest point in a process that limits overall performance. In EDI's case, the booking system acts as the primary constraint. Even though cars, instructors, and facilities are available, the outdated interface restricts how efficiently these resources can be scheduled. If learners cannot see available slots, they cannot book lessons, leading to idle instructors and slow progress. The bottleneck at the digital level holds back the entire organization's throughput, because every learner must pass through this system in order to advance in their training. Staff at EDI work diligently to support students, especially when the digital system falls short. Reception teams frequently assist learners with scheduling, answer questions about unavailable slots, and help reprint receipts or adjust bookings. While this personal support is valuable, it becomes overwhelming during peak hours. The volume of inquiries related to booking difficulties indicates that the digital system does not meet current demand levels. This leads to overcrowding at the front desk, increased waiting times, and a higher workload for staff. To address these operational challenges, a modernized booking solution is required. The proposed Smart Book system introduces a simplified, faster, and more transparent booking experience. Its foundation is real-time slot visibility, ensuring that learners see the exact availability of instructors and cars at any given moment. This real-time synchronization eliminates confusion and prevents the mismatch between displayed and actual capacity. The SmartBook system also features one-click booking, reducing navigation steps and accelerating the reservation process. A digital waitlist allows learners to queue for their preferred slots and automatically receive confirmations when openings appear. This reduces repeated checking and creates a smoother experience. The system also enables bulk booking, where learners can schedule multiple lessons at once instead of booking each session individually. This is especially helpful for intensive courses and students with strict timelines. While the SmartBook system improves the booking process, the flex capacity model focuses on optimizing instructor and vehicle utilization. Predictive scheduling uses historical data to understand peak periods and adjust instructor availability accordingly. For example, more instructors can be assigned during evenings and weekends when demand is highest, while fewer instructors may be scheduled during off-peak hours. Incentives can encourage learners to book during low-demand periods, helping distribute workload evenly. Cross-training instructors enhances flexibility, allowing them to teach different vehicle categories when needed, temporary capacity boosts, such as adding extra instructors or vehicles during exam seasons, ensure that EDI accommodates sudden surges in demand. Quality management also plays a vital role in sustaining improvement. The faster system updates, accurate error messages, dependable notifications, and real-time confirmations build learner trust. Continuous feedback from the students allows EDI to refine the system further, ensuring that it meets evolving expectations. Implementing these changes begins with a pilot group of learners who test the new system while others continue using the existing platform. Their performance, booking success rates, waiting times, and satisfaction levels become essential indicators of improvement. If the results are positive, the upgraded system can be expanded across all branches, ensuring consistency and high-quality service throughout the institute. By strengthening its operational strategy and adopting modern management frameworks, EDI positions itself for long-term efficiency. High volume and high visibility demand a well-designed booking mechanism that minimizes waiting, communicates accurate information, and aligns capacity with demand. The combination of SmartBook and Flex Capacity forms a comprehensive solution that addresses both digital and physical components of the learner experience. In conclusion, Emirates Driving Institute operates within a complex, high-volume environment where efficient processes are crucial.